So good morning, class. Unit 5 is trigonometric ratios. I would suggest that you read the little blurb on the big idea and learning goals so you know what to anticipate for the unit. And these are the breakdown of the lessons. Uh, Before we start, I have attached as a Google Classroom post the grade 10 trigonometric unit, the filled in version. So what you need to recall, for example, is that
If you have a right angle triangle,
and this is the reference angle. This is the adjacent side to this angle, and this is the opposite side to this angle. And meanwhile, the hypotenuse will always be the same, regardless of what reference angle I'm discussing about. So you gotta be very fluent with identifying these, and hopefully you can warm up to this idea. So please feel free to skim through. So for example, you should know the word SOHCAHTOA, that's the abbreviations, to help you remember this formula. Sine theta equals opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. So what you need to keep in mind is that there has to be this angle that is associated with this. Remember how in Unit 1 we discussed that this is the input of this function? So you have to always remember that there's a theta or an x that goes along with the sine, cosine, or tangent. So that is the primary trigonometric ratios, and all of these are the primary trigonometric ratios. When you solve for the a, that's when you're solving for the angle, whereas this whole thing is called the primary trigonometric ratio. So at this point, we're going to start Unit 5, Lesson 1, Primary and Secondary Trig Ratios. So this whole first page is review, but at the very end, it does go through like the more harder question from grade 10, and then we go on to the newer stuff. So the primary ratios are, as we saw from the other page, is that these are the sine, the cosine, and tangent. So for primary trig ratios, as you've seen from the previous note, is that you have sine theta is equal to opposite over a hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent, where we said that from Unit 1 that this sine portion is the function and the input is the theta. So f at theta and the function is sine and the input is theta.
meanwhile, try to recall what Pythagorean theorem is. It is the formula used to find the missing side of a right angle triangle.
Keep in mind this only works for a right angle triangle, and along with primary trigonometric ratios, they both only work for right angle triangles. So the equations are a squared plus b squared equals c squared. What does that mean? The c has to be the hypotenuse because
The area of C is made from the area of A plus area of B. In other words,
hopefully you know that it's coming from the fact that you can create little squares from this, and when you add up the spaces taken up by these squares, it will exactly add up the square made by the area with the length of C. So this is the hypotenuse, the longest side of a right angle triangle that is always across from the right angle. So let's talk about a couple scenarios. Previously, when I was referring to the grade 10 slides, I was telling you that there was a reference angle to consider because our opposite or adjacent are different depending on which angle you're looking at from. So I'm color coding so you know what I'm discussing. Is that if this is my reference angle, I am looking at this triangle from this angle, and I'm actually tilting my iPad so I can really envision what I'm talking about, is that this will always be my hypotenuse, but the opposite side is across from this reference point. when this is the reference point. So in red, I will write this is opposite to that reference point theta. Meanwhile, the side that is adjacent or beside that angle is this one. And you're going to write in adjacent. So what opposite and adjacent means is that opposite is that side that is across from the reference angle. Adjacent is the side that is adjacent from the angle.
Take a second to write down the definition of adjacent and opposite side as needed.
With this same triangle, keep in mind you can look at it from a different perspective. If you are at the beta angle with this color green, and you're looking at it from that angle, then the adjacent side is actually going to be right here. And the way I tell is the adjacent side is like touching the reference angle, whereas the opposite side never ever touches the reference angle. So I'm going to write in that this one is adjacent to beta. And meanwhile, the other side is opposite to beta. And I hope you're somehow color coding because otherwise it might be a little hard to tell or it might not be as obvious if it's all in pencil. Meanwhile, for question 2, so these are some typical questions that you dealt with in grade 10. So this is how I look at it. My strategy is that, well, I put a little curvy here just to show that that is an angle that I'm looking at. I don't do this every time, but just to be sure. And I don't actually label all 3 parts. Reason is, if there's too much information, it might throw you off. So what I do is, well, that's the hypotenuse right away. And the side that is represented by x seems opposite to the 3 degrees. Keep in mind that this side is not the longest side, and this is always the longest side because it's across from that 90-degree angle. So I have opposite for x. So that is x is equal to opposite side. 24 meters is the hypotenuse. At least on one time on the page, and just because I'm zoomed in, I'm writing it right here. I write SOHCAHTOA. And I have it right in front of me so I don't make a mistake. And what I do is I see this reference angle, I see opposite and hypotenuse. When I look at this, I see O and H in only one of the trigonometric ratio, and that is represented by the sine theta. So I'm going to circle that. You don't have to circle it every time. I'm just showing you for now. So you have sine theta is equal to opposite over hypotenuse. Well, because everything's nicely labeled, all you need to do at this point is sine 33 degrees because that was the only reference angle and I pointed out that is the reference angle that I'm talking about. And so you will have sine 33 is equal to, my opposite was x, so I'm going to write x divided by hypotenuse, which is 24. At this point, you're going to try to solve for x. And so what you're doing is cross multiply. And so you have x is equal to 24 times sine 33 degrees. So at this point, please try to use a calculator yourself rather than just copying down the answer, because if your calculator is accidentally in radian mode, which is like represented by the little r on top of your scientific calculator, you will get a different answer. You need to make sure that you're comfortable with switching from degree to radian and whatnot, depending on the question. And for now, I'm telling you that you need to be in degree mode for these questions, mainly because we're basically in degrees for the angles. Does that make sense? If we're dealing with degrees, we should be in degrees. Okay? We have x is equal to approximately 13.1 meters. So question B, so this is the reference angle. I'm going to start labeling at this point. So the 47 is opposite to my x, so I am going to write opposite there. And meanwhile, this side is adjacent. I'm using the primary trig ratios to help me solve for the x, because that was the original question. So I'm noticing that the words O and A are used. Therefore, I am going to circle TOA, because that's the only trigonometric ratio that consists of the letter O and A. I have tan theta is equal to opposite over adjacent, just until you get used to that formula at first. So I have tan, I don't know my angle, so I'm going to write x. So this time I'm solving for the angle, notice, and I'm not solving for the side like question A. I'm going to sub in opposite, which is 47, and then 32 for adjacent. So you're not done yet, and basically you have to reflect, how do I get x by itself when the function is tan? Well, you want to get x by itself, and if you look at your calculator, the second function to tan is tan inverse, if we're talking about it calculator-wise. So I basically need to do tan inverse of both sides, because that is a strategy I use to get the x by itself. What you do to one side, you have to do the other, and this will get rid of the tans on the left side. Therefore, on your calculator, you're going to find the tan inverse of 47 over 32. Notice that I have to always take tan inverse of 47 over 32. I don't usually put tan inverse on the right side of 47 over 32 because remember, this is the input and this is the function. I have to write it left to right in this particular order. And so I have x is equal to approximately 56 degrees when I use the calculator. Question C, now you notice that, you have these three sides. There's not really a reference angle other than the 90 degrees itself. So if I zoom back in, there were two kinds of things that we learned from grade 10. It's the primary trigonometric ratios, and that usually dealt with when we were dealing with like an angle and one or two sides. But when I don't have a particular angle and I'm dealing with all the sides, that means I should be using the Pythagorean theorem for this question. And the way you're labeling it is, well, this has to be the C, because I noticed that this is a hypotenuse. Whether you put this as A, or this as B, or this as A, or this as B, it doesn't really matter, because
the order of how you add doesn't matter as much as the significance of C. So for example, if you do 5 plus 7 or 7 plus 5, it's the same thing.
But I'm just going to write it kind of in order, so from left to right. So I'm going to say that's A and that's B, and this is a C. All right, Pythagorean theorem. And so I have as a formula, a squared plus b squared is equal to c squared. I'm going to sub in what I have, so 135.1 squared plus b squared is equal to 161.1 squared. So I will actually keep everything kind of exact, and I'm going to work algebraically to get the b squared by itself. So I'm going to do subtract my 135.1 squared on both sides. And I will get b squared is equal to whatever that works out to be. And I noticed that I got 7,701.2. Am I done? No, not yet. I need to get b by itself, and there's a squared on it. That means I need to square root both sides. Take square roots, I will get a positive or minus as the answer, but we're dealing with length, so I'm only going to grab the positive one. And so I'm going to write b is equal to approximately 87.8 meters. And you notice that in grade 10, we never talked about the positive and negative, partly because we were mostly dealing with length. And so with based on the curriculum, that's why we didn't mention to you that we have a positive and negative answer. So question 3, it says from top of a building, the angle of elevation of the top of a nearby building is 28 degrees, and the angle of depression of the bottom of the nearby building is 48 degrees. The distance between the two buildings is 50 meters. What is the height of the taller building? So at first, you need to recall angle of elevation and angle of depression, which is very easily forgotten, obviously. And so we have a diagram here. And basically, if this is your eyesight and this is your level, and this is your horizontal level, when you look up, that is your angle of elevation. And when you are looking down from your horizontal view, that is called angle of depression. So that is perhaps part of the note, and now I can actually go to the question. So at first, I'm going to start by drawing a building, and then I'm going to, from the top of the building, the angle elevation of the top of a nearby building is 28 degrees. What that means is I'm basically staring up to another building. And so this is how I'm going to draw the diagram. And so remember, I'm talking about angle of elevation, so I'm going to draw a horizontal line to also represent that as well. So I'm going to write in that this is 28 degrees, and that is represented by angle of elevation. Meanwhile, it says, and the angle of depression of the bottom of the nearby building is 48 degrees. The way you're going to draw that, from the shorter building to the taller building, you're going to look down to the bottom of the building, and that's what the angle of depression is. And so you get 48 degrees for this angle. Then we need to continue labeling the diagram. So the distance between the two buildings is 50 meters. So at the very bottom over here, I am going to label it as 50 meters. And then it says, what is the height of the taller building? And so you might do it two ways, but I'm noticing that I'm creating these like two little triangles. And so you might have just done like one straight line to represent that taller building, which was my first idea at first. But I'm going to kind of split it up so that I can actually add up these little triangles so that those two parts are going to add up to my complete height of the taller building. So obviously the diagram is super important, and for labeling sake, I'm gonna say this is triangle 1, the triangle right angle triangle 1, and triangle 2. And you know that because you're dealing with a perfectly horizontal line, that it is implied that this is 90 degrees. And that's why we're gonna be able to use SOHCAHTOA. So I'm going to write SOHCAHTOA once the primary trig ratio. I'm going to first discuss about one of the triangles at a time. So triangle 1, so I have 28 degrees. I have 50 meters for the bottom of the triangle, and I have this as x. And so at this point, I'm going to start labeling it up. So if this is my reference angle, x is the opposite because it's the side that never touches the 28 degrees. So the 50 meters is the adjacent. And as you label a lot of these triangles, right angle triangles, you get really used to the idea. So tan theta is equal to opposite over adjacent. And I have tan 8 degrees is equal to opposite, which is x, divided by adjacent, which is 50. I'm going to do cross multiplying at this point to get x by itself. And I will get x is approximately equal to 26.6 meters. So that is my first part. Now I'm going to move on to the second triangle. So I have the x figured out. I need to figure out the y eventually. So I'm going to talk about triangle 2 now.
So I have 48 degrees as my angle of depression because I'm looking down when I'm looking horizontally.
This part is equal to 50 meters according to the diagram, if you followed along, and this is y. At this point, I'm going to start labeling the opposite, hypotenuse, or adjacent. There is no hypotenuse that needs to be labeled. I do have my adjacent, and I am dealing with the opposite. So in this case, I have tan theta is equal to opposite over adjacent. Therefore, tan 48 degrees is equal to y divided by 50. At this point, I'm going to do cross multiply again, and I get y is equal to 50 times tan 48 degrees, and therefore y is equal to approximately 55.5 meters. So how are you going to conclude this question? Well, you can't just say therefore x equals that and y equals that. Sometimes a problem I'm seeing with the summative is that students are not really interpreting what's going on. You have to specifically label and identify what's going on. And so the height of the taller building, which is the original question, is made up by x plus y according to the diagram that I particularly drew. And so I'm going to have a therefore statement that says, therefore, the height is 82.1 for the taller building.